Okay, welcome everyone to our event. This is the Climate Talk with Dr. John Cook. And just a couple of housekeeping items. Everybody has been muted and your camera is off. You can certainly turn your camera on, but we ask everybody stay muted during the talk so that we don't have any interruptions or feedback or anything. The basic format of the event is we're going to do a couple of introductions about your co-host for the event, and then we'll hand it over to Dr. Cook, and he will do a presentation, 20-25 minutes, and then we'll follow by a Q&A. And for the Q&A, we want to organize that by you put your questions in the chat, and we will go through those questions and share those with John Cook and get his response to that, and we'll create the dialogue and back and forth when we do that. So very briefly, your sponsors are the co-hosts of this event are the Loudoun County chapter of Citizen Climate Lobby. And Citizen Climate Lobby is a group of, it's an organization that enables and engages citizens to work on solving the climate challenge. And it's a very, I think, well-organized group. We're organized at the chapter level is our goal to create the political will to make change happen in terms of getting climate change addressed. And so one of the main ways that we work on getting that is working on trying to get a carbon fee and dividend passed. And a carbon fee and dividend is essentially saying we're going to charge a fee at the source where fossil fuels are for the carbon content of those fossil fuels. And then we return 100% of that revenue to the people. And we see this as a very effective policy. And in fact, there is a bill already on the table from Congressman Deutsch, which was just recently introduced into Congress, the current Congress, HR 2307, called Powering America and Forwarding to Clean Energy. So we'll put some information in the chat so you can learn more about Citizen Climate Lobby if you're not already involved, and possibly get involved with your local chapter. Hopefully that's Loudoun, but if it's not Loudoun, wherever your local chapter is. And here I want to hand it over to Jillian and talk about Second Chapter Books, your other co-host tonight.
Good evening. I'm Jillian Brunette, and you see on your screen a shot of our bookstore. We're in Middleburg, Virginia, with our address, email, and phone number. For this event, we're going to be, we will be the bookseller. We're giving everybody a 10% discount on the books, and you can call us at 540-687-7016 to place your orders. You can send us an email to place your orders, or you can just wander into the bookstore. So this is the book. I don't know if you can see the book, but this is the book. And we'll have it here and have it available for you. They're all signed, will be signed by John. And it's a pleasure working with this group, and thanks for inviting us to participate. And I think it's going to go now to Greg.
Good evening, everyone. I have the pleasure of introducing our speaker for this evening. John Cook is a postdoctoral research fellow with the Climate Change Communication Research Hub at Monash University. His research focus is understanding and countering misinformation about climate change with an emphasis on using critical thinking to build resilience. He obtained his PhD at the University of Western Australia, studying the cognitive psychology of climate science denial. In 2007, he founded Skeptical Science, a website that won the National Center for Science Education Friend of the Planet Award. So now I'd like to turn it over to John. Thank you.
Thanks very much. And thanks both to CCL Loudoun for inviting me to speak. And also Jillian, who very generously came all the way over to my apartment in Fairfax a few weeks ago, just before I moved from the US to Australia, because it was the last day that I was in the country, and she came just to make sure that I got all the signatures to add to the book. So all those books that are behind her, they have hand-drawn cartoons of Cranky Uncle. And they were the last ones I did in America before I returned back to Australia. So those are limited edition there. Make sure you get them before they disappear. But enough plugging. I think I'll share my screen and jump into my presentation. Originally, my talk had a title that was something very academic about using critical thinking to build public resilience against misinformation or something along those lines. And then just 5 minutes ago, I decided to change it to something a bit simpler and easier to remember, getting cranky for climate. And I guess that's a double entendre there, because one, I think that we do all need to get a little bit cranky, or get fired up for climate action. That's what part of what we need to get that social and political momentum. But secondly, I guess it's also referring to how the Cranky Uncle game and book use critical thinking to build public resilience against misinformation. And I'm going to talk about some of the research that I've done and others have done into how do you push back against misinformation, how do you build public resilience so that misinformation doesn't have all these negative impacts on society, not just to do with climate change, but it really touches every aspect of society. And we've really seen that over the last 12 months. You all see my slides okay? We're good. Okay, all right, let me jump into it. I usually start presentations like this with just stating some of the obvious, and I apologize if this is super familiar to all of you and stating the obvious, but I think it is important before we talk about misinformation about climate change. It's good just to kind of set that foundation of accurate information about climate change. What do we know? And the story of climate change, even though climate science is super complicated and nuanced and sprawling, you can sum it up with just 5 key climate beliefs, which is a term that my old boss at George Mason University, Ed Maybach, termed, summarizing the 5 key things that people need to know about climate change. The first is that it's real. Global warming is happening, and we see signs of global warming all across our climate system. We see it in warming oceans, we see it in rising sea levels, melting ice, shifting animal species in response to a warming climate. Climate change and global warming is touching every aspect of our climate. And we also know that global warming is caused by human activity. Just as we see warming signs all across our climate, we also see human fingerprints or distinct patterns in climate change that confirm that human activity is the cause through the burning of fossil fuels, and ruling out natural causes which have driven climate change in the Earth's past. We know that the experts agree on these first 2 points. There have been numerous studies that have quantified the level of expert climate scientists' agreement on whether humans are causing global warming. And all these different studies come at this question from different angles, but all of them find an overwhelming consensus between 90 to 100%, and multiple studies have converged on 97% consensus. I was one of the co-authors of one of those studies in 2013, finding 97% consensus on human-caused global warming, and happy to answer any questions about that study during the Q&A later if people are interested. The fourth key climate belief is that the impacts from climate change are bad, and not just will be bad, but are bad. Climate is impacting the environment and our society now, and all across society and all across different parts of the world. It's not just something happening in the Arctic. It's not just something that's going to happen to our grandchildren. We're already seeing climate impacts now. And lastly, there's hope. We do have everything we need to be able to solve climate change. We have the technology to be able to transition from fossil fuels to renewables. We just need the political will and really the social will and momentum to be able to I guess, impose or compel our political leaders to act. And so, despite the fact that, let me just jump back again, sorry. And so, even though, as I said, climate change is complicated, really you can sum up the key story of climate change in just these 10 words. it's real, it's us, experts agree, it's bad, but there's hope. And so that's a useful summary from a communication point of view. If you're ever stuck on how to communicate climate change to people, you always have those 10 words. Okay, so while we have this expert consensus on climate change and human causation, there's a big gap between the expert consensus at 97% and the public. When you ask the general public, how many climate scientists do you think agree that humans are causing global warming? The average answer is around 67%. So there's this big gap between public perceptions and the experts. And that gap isn't equal across society. Over the last few decades, the public perception has been getting better. We have seen this gradual increase in acceptance of climate change and support for climate action. Things are getting better, but it's not getting better equally across society. We see that amongst Democrats, perceptions about climate change have been increasing, but amongst Republicans, it's been pretty level, pretty unchanging. And we see that polarizing effect even stronger on questions like trust in science. Going way back to like 1975, liberals and conservatives had equal trust in science. But over time, conservative distrust of science has been increasing steadily, while with our liberals, it's been slightly increasing. So there's been this polarizing influence, and misinformation has been a big factor in causing that polarization. And the polarization has gotten so bad that nowadays, when scientists examine what is the big drivers of people's attitudes about climate change, political affiliation and political ideology are the biggest factors by far. They trump age, education, income level. So the fact that it's who you vote for has a bigger impact on your attitudes about climate change than your education levels is quite extraordinary. Why should whether we vote Republican or Democrat affect our opinions about the greenhouse effect? One should not be connected to the other, but that's the state of the situation. I will note that this is primarily a US-based and Western countries-based phenomenon. Polarization is strongest in the US. There is polarization in Australia, it's not quite as strong. And then in the UK, Canada, and New Zealand, there's kind of weaker effects. But it is largely those countries where misinformation is most common and polarization is strongest. So I think it's important to recognize that it's not built into our human brain that we have to be polarized about climate change. Most of the world isn't. And B, just going back, it didn't used to be as polarized even in the US. So this current situation has been manufactured. It's not hardwired into the human brain. And so how does misinformation do damage? Like, why does this matter? Does misinformation actually have an effect? Can we ignore it? There's an interesting study run by Sander van der Linden back in 2017 that looked at how does misinformation do damage. And the way he ran this experiment was he showed participants in an experiment different messages. One message was the 97% consensus on climate change. A different message that he showed to different groups was some misinformation casting doubt on the consensus. And the misinformation came from a website called the Global Warming Petition Project, which featured 31,000 Americans who had got a science degree, who had signed a statement saying that humans aren't disrupting climate. And the point of this website is to argue that there's no scientific consensus that humans are causing global warming. Now, what they found in their research was in this bar chart, the first bar were people who were only showing the 97% consensus. And they found that for that group, the message about consensus had a strong positive effect. It not only increased their perceptions of the scientific consensus, but it also increased their acceptance that global warming was happening and human caused, and increased their support for climate action as well. The second bar here is the group of people who were only shown the misinformation about the global warming petition project. And here we saw a significant negative impact. So as you would expect, misinformation does reduce people's public perceptions, reduces their acceptance of climate change, and reduces support for climate action. But the third group here had no effect. This was a group who were shown both the fact and the myth. And what they found was the two cancelled each other out. And this is really important for anyone who does public engagement or talks to people about climate change, or really talks to people about any facts, anyone who's got an interest in communicating facts to other people. Because what this means is facts can be cancelled out by misinformation. And even if we work hard to communicate our facts well and clearly, all that good effort can be cancelled out by a myth. The reason why this is so is because of this dynamic. And we see this in old episodes of Star Trek, where Captain Kirk gets cloned and there's a fake Kirk and a real Kirk, and Mr. Spock has to try to figure out which is the fake and which is the real. That's the same dilemma that the general public have with all this conflicting misinformation flying around. Which is the fact, which is the myth? If they have no way of resolving the conflict between the two, then often they disengage and just choose, like, just don't believe either. And so that means that misinformation doesn't have to be necessarily convincing or based on evidence or coherent. It just has to exist, and that can play a cancelling out effect and cancel out accurate information that we're trying to communicate to people. But this dynamic of people not being able to resolve the conflict between fact and myth also points to how we can counter misinformation. And the secret is we can counter misinformation by helping people resolve the conflict between fact and myth. Give them the tools to be able to tell the difference between accurate information and false misinformation. And a useful framework for doing that is inoculation theory. This is a branch of psychological research dating back to the 1950s. It actually began, interestingly, with researchers trying to figure out a way to inoculate American soldiers who were, I think at the time, were going to fight in the Korean War. When soldiers were captured and made POWs, they were often in captivity brainwashed by the enemy. And so scientists wanted to think, can we inoculate our soldiers from being propagandized and brainwashed? Since then, since the 1950s and that military origin, inoculation theory has branched out and expanded across a whole range of areas, including science and climate science. And the idea of it is take the idea of vaccination and apply it to knowledge. Just as exposing people to a weakened form of a virus can build up their immunity when they encounter the actual virus, and this is certainly a concept the whole world has been obsessed about for the last year. In the same way, exposing people to a weakened form of misinformation can build up their immunity, their resilience, so that when they encounter the actual misinformation out in the world, they're less likely to be influenced and misled. And here's an example of the inoculating message from that experiment with the climate misinformation. What the inoculating message did was it explained several of the ways that the misinformation misled. Firstly, it was an online petition, so there were lots of fake names due to the lack of quality control. There were Star Wars characters, there was characters from MASH and long dead characters like Charles Darwin. 31,000 seems like a lot, but it was 31,000 people with a science degree. while there are millions of people with science degrees. So 31,000, while seeming like a large number, was a tiny fraction of the total pool of science graduates. And lastly, because it was anyone with a science degree, it was science graduates across all these different fields: computer science, veterinary science, mechanical engineering, ag science. But less than 1% of the signatories had any actual relevant expertise in climate science. What the researchers found was when you inoculated people before showing them misinformation, the inoculation mostly neutralized the misinformation, and the facts were able to have a positive effect again. And so, so the researchers concluded that inoculating people, preemptively getting out there and letting them know of how misinformation misleads them, is a way to build up people's resilience and neutralize the misinformation. Now, at the same time that these researchers were doing this experiment in the US, I was in Australia doing my PhD, and I was doing a very similar experiment, but with a slight twist, a slight different angle. Firstly, by coincidence, I was running an experiment using the same misinformation, the Global Warming Petition Project. And I found that when I showed people misinformation, just as in the other experiment, it did have a negative effect. This graph shows the change in perceived consensus. Anything below the dotted line means it had a negative effect. And the horizontal axis in this graph is political ideology. People to the right are more right-wing, people to the left are more left-wing. And so what I found was climate misinformation has a disproportionate effect on people who are more politically conservative. So what this tells us is misinformation has a polarizing effect. The general public respond differently to misinformation, so that as misinformation goes out in the public, it pulls people apart. Liberals end up in a different place to conservatives. And so that's part of the reason why misinformation has had this polarizing influence on the public. I also tried inoculating people before showing them the misinformation. But in my inoculating message, I didn't mention the Global Warming Petition Project at all. Instead, what I did was I put the focus on the technique of fake experts, using people who convey the impression of expertise, but didn't have any actual relevant expertise. And I used tobacco misinformation going back to the mid-20th century as an example of the fake expert strategy used to mislead. Now, in trying to inoculate people without even mentioning the myth that I was inoculating them against, I still found that it completely neutralized the misinformation. The blue line here is the people who were inoculated before being shown the misinformation. And even though there's a slight slope to this line, statistically, it's like a horizontal line at zero. The misinformation was completely neutralized across the political spectrum. And what this tells us is whether people are liberal or conservative, nobody likes being misled. So explaining the techniques used to mislead works across the political spectrum. And so my work since then has been focused on how do you explain the techniques used to mislead. And I've found a very useful framework for that, the 5 techniques of science denial. And I summarize them with the acronym FLIC. It makes it easier to remember: fake experts, logical fallacies, impossible expectations, cherry picking, and conspiracy theories. I'll give some examples of those shortly to make it a bit more tangible. And actually, I'll give you those examples right now. So the first one is fake experts, and the Global Warming Petition Project is a supreme example of that. And the thing about fake experts is, in real everyday life, we don't tolerate people who don't have the relevant expertise when it comes to things that matter. If we were getting heart surgery, we wouldn't want someone with a computer science degree performing the surgery. We want the relevant expert. And the same should apply to climate science, which is also a complicated scientific topic that requires the relevant expertise. And yet, fake experts are often deployed to mislead the public, and they're very persuasive. The Global Warming Petition Project is one of the most persuasive climate myths out there in terms of reducing people's acceptance of climate change and support for climate action. And so educating people about this danger of using fake experts to mislead is a really important part of neutralizing climate misinformation. And yeah, again, the Global Warming Petition Project was the one that both our Sander van der Linden's research and my research focused on. And I think in hindsight, rightly so. We both published our studies in 2017. In 2016, during the election period, that 6 months in the second half of 2016, the most viral article about climate change on Facebook was the petition project. So more than articles about by the IPCC or the National Academy of Science or NASA or any scientific paper or anything that any climate organization did, this was the most shared article about climate change. And so it's viral, it's effective, and it needs to be neutralized. The second type of denial technique is logical fallacies. And this is actually a broad umbrella. There are lots of different logical fallacies, but the general structure of a logical fallacy is an argument where the conclusion doesn't follow from the premises or starting assumptions. It's also known as a non sequitur, which is Latin for it does not follow. So for example, the argument, I have blue eyes, therefore I know quantum physics. The argument here is the premise or starting assumption is I have blue eyes, and the conclusion is therefore I know quantum physics. Obviously, the conclusion does not follow from the premise. Just because you have blue eyes has no bearing at all on whether you have skill in quantum physics. But there are different logical fallacies, such as red herrings, ad hominem attacks, and fallacies such as the single cause fallacy or false dichotomy. I'm just going to give you an example of the most common logical fallacy you're going to find in climate misinformation. And it's the argument that climate is changing now naturally, or in other words, climate change now is naturally caused because climate has changed naturally in the past. And this argument commits single cause fallacy. It's assuming that whatever caused something in the past must be the same cause now, when you can have multiple causes. And it's exactly the same logic as arguing that a person who has obviously been murdered, like you can see, you know, they might have a knife sticking out of their back. I used this cartoon with school kids a few weeks ago, and then I was told I probably shouldn't have. I'm not sure. So I apologize if this is, it's a cartoon, so hopefully it's not too shocking. The argument that a person must have died of natural causes now because people have always died of natural causes is obviously a ridiculous argument in this context, but it commits the exact same logic or the same fallacy, single cause fallacy, as arguing climate has changed naturally in the past, therefore what's happening now must be natural. It's obviously false logic, but it's such a ubiquitous common climate myth. It's almost a knee-jerk reaction when a climate denier hears the term climate change. They'll go to, oh, I believe in climate change. Climate has always changed. It's almost a knee-jerk reaction at this point. So understanding the fallacy behind that argument and having analogies like this one can help in responding to it. The third denial technique is impossible expectations. And this is a technique that the tobacco industry perfected in the mid-20th century, demanding impossible or higher and higher levels of scientific proof in order to delay acting on the science. In the case of the tobacco industry, in order to delay, I guess, policies or regulations that made it harder for the tobacco industry to sell their cigarettes to the public. And we see it also with climate change in terms of attacking climate models, saying that they need to be perfect before we trust them. We saw the same kind of arguments on the COVID epidemiological models, like saying if they're not perfect, then we can't trust them, and therefore we should do whatever we want in response to COVID. It's that same technique of impossible expectations. And the problem with this is that science is never 100% certain. That's just not how science works. Science always provides a range of estimates. Even when they're taking measurements, measurements always have a range of values. And so scientists will, often they know something bad is going to happen. They just have a range of how bad or when it's going to happen. And when climate deniers say, well, you need more certainty, that doesn't change the fact that this bad thing is coming down the road. And that this cartoon is meant to illustrate that. The fourth technique is cherry picking, which involves focusing on a narrow part of the puzzle while ignoring the bigger picture. And this is a lot like being on the bow of the ship as it's sinking and arguing, well, I'm going up and therefore the ship can't be sinking. Obviously, it's not looking at the big picture. And you know that somebody's cherry picking when the conclusion that they come to from the data that they're citing is different to the conclusion you would get if you looked at the full body of evidence. And an example of climate cherry picking is the argument that global warming isn't happening by looking at short periods of the temperature record. Over the last half century, we've seen a constant long-term warming trend, but the temperature record jumps up and down from year to year because the ocean cycles are constantly exchanging heat between the oceans and the atmosphere. And so because the temperature record is jumping up and down, climate deniers are able to just find any short period where it looks like the temperature is not rising. So you can have a long-term warming trend and still find any period throughout those 50 years where it looks like the temperatures aren't warming, just through careful cherry picking. Conspiracy theories are inevitable when you deny a scientific consensus. When all of the global community of scientists agree that humans are causing global warming and you disagree with that, how do you explain how all the experts disagree with you? Inevitably, science deniers resort to conspiracy theories. And we've seen that in climate change for years, decades even. And often conspiracy theories seem ridiculous and they're ridiculed, and kind of rightly so they're ridiculed. But also conspiracy theories can be very dangerous. They erode trust in institutions, whether it's scientific institutions or scientists or scientific data, or even democratic institutions. And this year has seen the dangerous impact that conspiracy theories can have when it spills over from the dark corners of the internet and penetrates like mainstream society. So those are the 5 techniques of science denial, and that's really just a very quick kind of crash course on them. And it's really also just touching the surface, the tip of the iceberg, because the techniques of science denial are a broad landscape. And over the last decade, I've been building up a taxonomy of all the different misleading techniques used in climate misinformation. And it's a lot to take in. And this is from a communication and education point of view. This has been a big challenge. Not only how do you explain all of this? Like, I only just touched on the top 5, and that took me about 10 minutes or something. That was a lot of information, and there is a lot more to take in. How do you not only explain and introduce them all to people, but also get people to internalize them so that when they encounter misinformation, they can see, they can quickly and instantly see attempts to mislead them. Over the last decade and a half, I've been researching how to inoculate people against misinformation. Now, I've came up against 3 big challenges. And the first is psychological. Critical thinking is hard. Our brains are hardwired for quick thinking, for fast, instant decisions. We rely on all these mental shortcuts to get us through the day. That's just how our brains are hardwired. And stopping to critically think and reason through, is an argument logically valid? Does it contain any fallacies? That is hard critical thinking, and our brains just find it cognitively effortful and difficult to do that. And so I'm coming up against a big, basic, fundamental psychological challenge there. How do you overcome the difficulties of critical thinking if you're trying to build resilience amongst the general public? And by accident, I happened upon a solution to that, and the solution is games. In 2018, maybe it was 2019. In 2019, I started developing it was 2019, a game that taught critical thinking. And it was, I'd actually just finished the Cranky Uncle book. I finished the manuscript, I'd sent it to the publisher. It was like a year of exhaustive work. And then I thought, well, what do I do now? And I started exploring the idea of taking the content from the Cranky Uncle book and putting it into a game form. And as I worked through that, I took Flick, I took those techniques of science denial, and I basically structured a game so that Cranky Uncle was your mentor. He taught you how to become a cranky uncle yourself, like a science denying cranky uncle, by explaining all these different techniques of science denial. And this is an approach called active inoculation. Everything I've been talking about up to now has been passive inoculation, where somebody explains the techniques of denial to an audience in a one-way direction, and the audience is passively receiving that explanation. But in a game with active inoculation, the player is actively interacting with the content and learning the techniques of science denial by essentially kind of learning how to become a cranky uncle and do those techniques of science denial themselves. It's kind of a almost perverse, dark humor way of inoculating people. And so what the game does is Cranky Uncle explains each of those techniques of denial kind of in the same way that I just explained them, but maybe in a gruffer, more cranky way. And it also, the game uses cartoons to illustrate the different fallacies in a more concrete way. What I think is the most important aspect of the game is not only does it introduce and explain techniques of science denial, it also gets you practicing critical thinking to earn cranky points, to get further into the game and level up, so that as you level up, your mood gets crankier and crankier. You have to fill out these quiz questions where you're shown examples of misinformation, and you have to identify what is the science denial technique in that particular myth. And by practicing spotting fallacies over and over again, you're basically practicing critical thinking. And the more you practice it, the quicker and easier it gets. And so all those elements of gameplay help overcome that psychological challenge, because it takes that difficult task of critical thinking, and through repeated practice, it makes it a quick, easy task. And so a way to summarize that dynamic is the best way to stop a bad heuristic or mental shortcut is with a good heuristic. That idea of practicing so then you can quickly spot fallacies is like a good heuristic. That's just a very nerdy take on an NRA talking point. The second challenge of inoculating the public against misinformation is structural. How do you reach siloed communities? Because the way that society is structured now is people get their information from these echo chambers, whether it's a cable channel that just delivers the type of information that agrees with their existing beliefs, or social media that also hand delivers content that their algorithms tell them you're more likely to click and like because you already agree with it. So the media landscape and social media landscape is designed to just keep people in these siloed communities. That means that even if I came up with the perfect inoculation message, how do I get it into these siloed communities? And I found an answer to that kind of by accident. As I was developing the game and talking to climate scientists about it, I was taken aback, really impressed by how enthusiastic these scientists were, who were also professors teaching classes. They were very enthusiastic about using the game to teach critical thinking to their students. And this was climate scientists all across the country, in red states and blue states. And I realized that classrooms were a really powerful way to reach parts of the community that I normally wouldn't be able to reach, and who really needed to have access to this kind of content, building resilience against misinformation. And so over the last few months, I've developed a teacher's guide to Cranky Uncle to make it easier for educators to use the game in classrooms. And I found that over the last just couple of months, actually, I need to update this. This is an old map, but teachers are from, I think it's 32 states across the US have signed up for the game. And also, as well as a number of other, around a dozen countries around the world. And we've just got started, so it's early days yet, but I'm already encouraged by the geographic spread, red states and blue states signing up to use it. Haven't cracked the Dakotas or the Carolinas yet. I'm really, really keen to try to, it vexes me that I haven't been able to get into those areas yet, but we're still working on it. And the other thing that surprised me was the age range, from middle school to grad school, from grade 5 or from grade 5 to, like, I guess what would grad school be, like grade 15 or something. So so this game is being used across a surprisingly wide age range, and we're collecting data to see just how effective it is at these younger ages. It'll be interesting to see what the kind of bottom limit is. And it's also being used in classes, not just about climate change and environmental science, but also in English, history, geography, philosophy, psychology, math, physics, chemistry. It turns out critical thinking is relevant in all topics. And because the game uses examples of misinformation across many different topics, that critical thinking aspect makes it relevant to all subjects. I'm nearly finished here. Thank you for your patience in bearing with me. The last challenge of inoculating the public against misinformation is social. We saw at the beginning how the biggest driver of climate attitudes is political affiliation. Political affiliation not only influences how you your attitudes about climate change, it also influences how you respond to the information about climate change. And we also saw that. I showed you how political conservatives are disproportionately affected by misinformation. So what that means is political affiliation is really another way of saying our social identity, our tribalness. Tribality is biggest driver of attitudes about climate change. Tribalness can often have very toxic influences on society, not just in climate change, but across a whole range of issues. But the thing about games is games can use that tribal instinct for positive outcomes. So what we're working on now is a cranky contest feature where groups can sign up and then challenge other groups to a cranky contest where each group can sign up with a code and then keep track of how, which group has collected the most cranky points. And this is just a basic version. We're hoping to add more sophisticated contests to the game later in the year. But the idea of it, either way, is appealing to people's tribal instincts to motivate them to play the game more, which builds their resilience against misinformation. So while tribalness or tribality typically has a polarizing influence in climate change and makes people more vulnerable to misinformation, through games, you can actually use those same tribal instincts to motivate people to become more resilient against misinformation. So that's something we're probably next week. I'm gonna start making cranky contests available. So if, for example, CCL Loudoun wants to challenge other CCL chapters to a cranky contest, yeah, please get in touch with me and I can help organise it. Last thing, if you're interested in playing the game, you haven't played it yet, you can play it on iPhone, Android, or on a browser on your computer. So there's our goal is to make it free and as accessible to everyone as possible. And I think that's all I was going to talk about. I will probably stop sharing my slides. Hopefully, if any of you wanted any of those URLs, you've got them already. I can always put it up later if people want it. And happy to answer anyone's questions.
All right, thank you very much. That was really excellent, and I can concur that I've played the game myself, and I thought I was pretty good at critical thinking, but certainly have felt like it's honed my skills. So I would recommend it for anyone who's interested. Maybe just to kick things off, I guess as I've thought about playing the game, and I've thought about my friends who are more of skeptical about climate science, I'm just thinking, how do I get them to actually play the game, right? It's you're preaching to the choir, right? I'm sort of already in the loop, and although I think the critical thinking I learned is good, but how do I get the people that I'm engaged with that are climate deniers to take that inoculation? Have you had success with that kind of one-on-one type effort?
Yeah, I mean, ultimately, our hope is to build into the game like features like invite your friends to play or challenge your friends to a cranky contest, and so that will tap into those competitive instincts. At the moment, people, like, one thing I found, like with classrooms using the game, is the progress screen on the game shows how far into the game you are, what your cranky level is, and also a picture of the cranky uncle's face, which gets redder and crankier the further you get into the game. You know you're doing well when steam starts coming out of his ears. So what one class was doing was students were posting a screenshot of their progress, and then that got other students, motivated them to try to go past that other person and get an even crankier progress screen. So I guess that's one way you could, the people doing it, they say, here's how cranky I got. Who can beat me?
Yeah, I'll try that. So we do have a few questions from the presentation, so maybe we can start with that. So I believe this goes back to one of your earlier slides. So Greg asked, what caused the acceptance of climate change to rise and then drop in the early 2000s?
Yeah, that's a really good question. So when you look at public data of people's attitudes about climate change over like long term, you see it's just a very steady increase from when the Yale data started collecting in the mid 2000s to now. But then around 2009-ish, there's this kind of precipitous little valley where public attitudes about climate change drop. And then it took like nearly a decade to kind of get back to those baseline levels. And there's been a couple of studies looking at, well, what caused that drop? What was it to do with economic factors? There was like I think Americans call it the Great Recession. The rest of the world calls it the global financial crisis. Or was it other factors? And two analyses, one by Mildenberger and Leisowitz, and another by Bob Brule, both find that the biggest driver of public opinions about climate change and that drop was elite cues. In other words, cues from political leaders. In other words, misinformation coming from conservative political leaders. And so there was this big surge of misinformation coming from political leaders around that time. It was heading in towards COP15 at Copenhagen, and it was the Copenhagen Climate Summit was being billed as a really significant one for getting climate action and global cooperation. And so climate deniers kind of rallied and just did this big surge of misinformation preemptively to try to neutralize the COP. And that big wave of misinformation did have an influence on public perceptions.
Okay, so that actually is a good segue to our next question. Our next question was from Steve, who asked, Steve Shelby, and I see he's got another question, but I'll go ahead and ask the one he asked earlier, is it possible that it's the other way around? Could beliefs about climate change be determining who people vote for? So you're saying who you vote for determines your beliefs on climate change, but it could be filtering. Could the filtering be happening in the other direction? Is there research that proves the cause and effect there?
Yeah, that's a good question. So there's two ways that scientists measure whether two things are connected. There's correlational studies where they might just do a survey and ask people, what do you think about this and what do you think about that? You know, who do you vote for? What's your attitudes about climate change? And then if they find that the two correlate, then the scientists conclude these two things are linked. But that correlational studies or surveys don't tell us which direction the causation goes. Mm-hmm. It just tells us that there's a relationship, or maybe there's a third factor that is driving both. And that comes back to that single cause fallacy that I was talking about, or false cause fallacy. So that's important. Yeah.
So in this case, is it just a correlation, or is there a causality that can be identified?
So the second way that scientists can work out causal links is through randomized experiments. And in those cases, you have like two groups who are demographically the same to try to rule out other kind of possible influences. And then you just show them different messages or stimuli of some sort. And that's a way to work out if one thing causes the other. So maybe giving you a concrete example helps. There was a study that split people into two random groups and showed them two different messages about climate change. One message was climate change is real and we need to regulate polluting industries like the fossil fuel industry. So it was a climate message with the solution of regulating industry. The second climate message said climate change is real and we need to reinvigorate the nuclear industry in order to solve climate change. What they found was political conservatives or Republicans reacted very differently to those two messages. They hated the regulation message, but they liked the industry-friendly message. And their attitudes about climate change changed accordingly. So the exact same climate information, accurate information, had a different effect depending on what the response to the climate information was. And so what the scientists concluded from that randomized study was political affiliation does drive how people respond to climate information because of that randomized element. And basically solution aversion, or not liking a certain solution to climate change, is a driver of why people reject the science about climate change. In other words, people don't like the solution to climate change, so they reject that there's a problem in the first place. Yeah, so to answer the question then, it is mostly affiliation, that like politics, that drives attitudes about climate change, not the other way around. That's not to say that it's 100% that way. It is possible that there can be a bit of bleed in the other direction as well, but the bulk of the causal effect is politics driving climate.
Okay, that's good to know. I want to keep going here. We've got a lot of questions popping up, and so I want to keep trying to move things forward. In that vein, and this is actually for me, but it came up while in the course of the presentation, so I still want to ask it. You were talking about conspiracy theories, and what occurred to me is, how much do you think the sort of things are happening? You know, you could argue that your explanation is a conspiracy theory, right? In terms of that, what's creating denial is a structured, systematic effort. But I guess the real question is, how much of that do you think is happening? How much is this denial like an orchestrated effort versus, I don't know, just a normal range of opinions that people have?
Yeah, so real conspiracies do exist. Volkswagen really did conspire to deceive the public about how much pollution their cars were emitting. The tobacco industry were convicted of conspiracy to deceive the public about the health impacts of smoking. But myself and Stefan Lewandowski wrote a handbook, the Conspiracy Theory Handbook. And in the opening page, we address your question. How do you tell the difference between a real conspiracy and a baseless conspiracy theory? And the answer to that is real conspiracies and baseless conspiracy theories have telltale traits to them. Conspiracy theories baseless conspiracy theories have these red flags, such as, well, and I have another acronym for that, CONSPIRE, which stands for contradictory, overriding suspicion, nefarious intent, conspire. Something must be wrong, persecuted victimhood, immunity to evidence, and reinterpreting randomness. And that, sorry, I just dumped all that on you. The Flick taxonomy includes the 7 traits of conspiratorial thinking. And actually, just over January and February, I added all 7 to the Cranky game. So if you get all the way to the end of the game, you will have internalized those 7 traits of conspiratorial thinking. And being aware of them helps you see those red flags of a baseless conspiracy theory. So if you see someone who is immune to evidence, you present an argument that disproves their conspiracy theory, and they just conclude, well, obviously that evidence was created by the conspirators to deceive us. They're immune to evidence, they can't be changed. Someone like conventional scientific thinking is open to evidence. So if someone's presenting a conspiracy and you present evidence and they're open to changing their minds about it, or just in general, if people are open to evidence and able to change their minds, that's how conventional scientific thinking works. Another trait of baseless conspiracy theories is overriding suspicion. If they're distrustful of scientific institutions, they think that NASA are faking data and climate scientists are tweaking the numbers, and they don't trust the World Health Organization, they don't trust the CDC. Those are red flags of baseless conspiracy theories. A genuine scientific thought has healthy skepticism. They assess the evidence before coming to a conclusion, but they don't dismiss any evidence that they disagree with, or they don't distrust scientific sources in general.
All right, that makes a lot of sense. So our next question is, a lot of misinformation is spreading over social media and the internet. what should social media and internet companies do to prevent the spread of misinformation? How can they apply inoculation techniques? And that was from Nathan Souls.
Yeah, so there's a lot that social media platforms can do. And they've been giving a lot of excuses over the years, saying it's technically too hard to respond to misinformation. Then last year, we saw how proactive they were in taking down COVID misinformation and election misinformation in November, December, and January. So that kind of put a lie to the excuses that it was technically too hard to counter misinformation. It's more a question of will. How willing are they? And I think it's actually a shame that they'll often be proactive on issues like COVID, but they say, well, they don't apply those same standards to climate misinformation. They don't think that climate misinformation is the same danger that COVID misinformation is. And while COVID is certainly an immediate threat, climate change is a huge societal threat that I think that misinformation does need to be proactively taken down. So how can they do it? One way is they're using their algorithms to either downplay or take down misinformation, not letting it spread or slowing its spread. Secondly, they can penalize serial offenders, people who have been flagged as posting misinformation. They can either suspend them temporarily or suspend them permanently. And we all saw the country take a deep breath when President Trump's Twitter account was taken down. I think that was a huge societal good, that action. Thirdly, they can flag misinformation. So that's where inoculation could come in. They could, if there's a post that's been flagged as misinformation, they could either, and they sometimes do, they could either link to fact checks or just explain how the misinformation misleads. And there's a number of different ways that can be approached. And fourthly, they can publish accurate information or fact checks. This is what Facebook is currently doing. They've published the Climate Science Information Center, which began as just a page of accurate information from authoritative sources like NASA or the IPCC or the National Academy of Science, just general authoritative sources. In the last few months, they started publishing fact checks of common myths about climate change. And disclaimer, I've actually been working with them on those. So that's been a collaboration between myself, Tony Leiswitz, who I actually mentioned earlier, Sander Vanderlinden, who I actually mentioned earlier. It's a small community, this climate misinformation researchers. So the three of us have been doing some of the like, I guess, leading research on climate misinformation, and we've been collaborating with them on writing fact-checking content.
Right. A long engaged supporter of CCL is Catherine Hayhoe, and we're all big fans of hers. And I believe I've seen her posting that where Facebook tags some of her posts as political or something like that, which is, I think, also sort of detrimental if they're taking something that's coming from a qualified, trusted voice and then tagging it in that way. And I don't know if they still do that, but I know there were some posts I saw where she got tagged as having stuff that was seen as political or not neutral or scientific.
There are a lot of ways that Facebook have handled climate change that is problematic. So a lot of it is sort of algorithmic. Like, there are challenges, technical challenges in identifying posts about climate change and then teasing out whether it's misinformation or not. But there's also human decisions, and so like a human decision to tag any climate post as political is problematic. It's kind of the easy wrong solution. They need to have a more nuanced. But one thing I've learned from my collaboration with them is that they have a very incremental approach. They kind of do something, test, do something and test, and it's this sort of step. So it takes time, and they're gradually just easing their way through. And while I think all of us would like it to go quicker and more proactively, they are moving in a direction.
Okay. All right, we got a few more questions, so I want to keep going here. So Janet Bing asked, we have a lot of teachers of freshman English that teach logic. How many of those have tried the game? Is it a large group?
So there have been some English teachers. It's been kind of a small group within the pool of teachers, which it has tended to be science-based. That could be more a reflection of the type of, because I've only been promoting the game and the teacher's guide on social media or on the Cranky Uncle website. And the type of people who have been following that tend to be more climate-based or science-based. So I think that's why it's mostly science teachers. But that said, it certainly works in the English context. I just need to find, I guess, ways to just, I guess, outreach, promote the game and the teacher resources to the community of English and humanities teachers.
All right, very good. We got two more questions. One I may actually let the person ask the, well, we got another one coming here, actually from the same, but I'm going to ask this one first. So do you think that if the clean energy lobby starts outspinning the fossil fuel lobby, that political views would change? That's from John Cartmill.
Outspending the fossil fuel lobby, was that the question?
Yeah, so I guess that's kind of going with the, there seems to be evidence, you didn't specifically call it out, but I think a lot of us have heard how, the fossil fuel industry has funded the disinformation machine that's kind of spread the doubt, the climate denier doubt. So I guess the question is, can we, the people who are pro-climate lobby, spend more money and offset that by, I guess, having as loud a bullhorn or a bigger bullhorn?
So the fossil fuel industry have spent billions funding organizations that promote climate misinformation. Billions just going to organizations. That's not even count. Like, I'm just citing research by Bob Burrell. That's not even counting the money spent on PR companies. I don't think it's possible for like climate groups to outspend the richest industry in probably human history. But what we can, we might not be able to outspend them, but what we can do is out-communicate them. And so, yes, I think we do need to pour as much of our time, energy, and whatever resources we do have into communicating the like climate solutions, the positive impacts, the co-benefits from clean energy, not just environmental benefits, but also health benefits and equity benefits, societal benefits, and also pushing back against not just climate science misinformation, but misinformation about climate solutions. We actually have research coming out well, it's currently under review, but we have, I'm just going to type the URL in here because you can see a preprint, like a preview of this paper. Well, I think I was about to send it as a direct message. Let me send it to everyone. We did some research that created, like we constructed a 20-year history of climate misinformation across different categories. And the science misinformation is actually a small percentage of climate misinformation, and it's on the downturn. The growing proportion of climate misinformation, and getting bigger every year, is solutions misinformation. In other words, misinformation that either attacks renewables or attacks climate policy, whether it's a fee and dividend policy or other, other kind of climate policies that are proposed, basically saying renewables won't work, they'll kill birds, they're harmful, they don't work at night time, they don't work when the wind blows. Policies are going to destroy the economy if we have a carbon fee that's going to raise prices and disproportionately hurt poor people. All of these false arguments are growing. They're becoming the bigger and bigger proportion of the misinformation landscape. And so we need to get ahead of them. We need to be developing resources, pushing back against the misinformation. And one thing about the misinformation research is responding to misinformation doesn't have to be a necessary evil. It doesn't have to be a negative kind of action. We should always respond to misinformation by communicating like the sticky facts that dislodge the misinformation. And often the sticky facts with climate solutions is telling those positive stories on how how climate solutions have all these positive co-benefits.
Right, and I'm hearing that message a lot more these days. So a couple of more questions that came up to keep things rolling and make sure we address what folks are looking for. So Chris asked, do conspiracy theories also tend to deny the humanity of a political opponent? We may think that the fossil fuel executives lied to preserve their salaries, and we would be right. That is actually normal human behavior. But climate deniers tend to argue that climate activists desire to destroy the economic system that they themselves depend on, which seems like an oddly motivatless conspiracy theory. I would add to that one of my favorite climate deniers, which many of these people know that I deal with, likes to comment on how the scientists are doing it so that they can make all this money. But anyway, I'll let you answer Chris's question about the denying humanity, the humanity of political opponent.
Yeah, it's a really good point. One of the traits of conspiratorial thinking is nefarious intent. Conspiracy theories often have these very vivid villains, whether it's satanic Democrats drinking the blood of infants to live long lives, or climate scientists who are all colluding for either money or to take away people's freedom. But the common thread across all these different conspiracy theories is these evil villains. And the challenge there is that I was just talking about telling the positive stories about climate solutions, but conspiracy theories are also telling these stories with strong, vivid characters. And that's compelling communication. People respond to stories, and simple stories. And conspiracy theories are often simple. And while we have the challenge of trying to communicate the complexities of climate change, just telling people, well, you can't trust climate activists or climate scientists or politicians advocating for climate action because they're evil, or they have some particular motive. Dehumanizing people, othering them, is easy messaging. It's effective because, as we've established, humans are social animals. We're tribal, and we respond to social messaging. And so it's a very the other thing that our machine learning research from that paper I linked to, the other thing we found was that attacks on scientists was another very dominant category of climate misinformation, or attacks on just anyone working on climate change, personal attacks. And so we do need to be able to respond not just to misinformation targeting climate solutions, but misinformation demonizing people working on climate change, whether it's scientists or activists or politicians or media or whoever. So yeah, there's a lot of work to be done.
All right, good. So I think I now understand the question that Chris had commented on that I was going to ask him to, but I think I get it now. So Chris points out one of our big things that we do as citizen climate lobbyists is we write letters to editors because we're trying to build political will. And so that's a real common tool we use. So would your advice on climate communication in terms of how we talk about it apply to our letter to editor efforts, to that form of discussion?
Yes, I think that the principles of climate communication apply, whether it's you're doing online communication or a letter to the editor or a Facebook post or just having a conversation. The general template that I follow whenever I'm responding to misinformation is fact, myth, fallacy, fact. What is that key sticky fact that I want to communicate? What is the myth that I'm responding to that's related to the fact? And then what is the fallacy that the myth commits? And because of that, because you have fact and myth, you want to help people resolve the conflict between the two. And you do that by explaining the fallacy. And then you just end by reinforcing that key fact. What's the main thing you want people to take away? And that fact, myth, fallacy, fact format, I've used that with little infographics that I'll throw on Instagram or Twitter. I've used it in letters to the editor when responding to attacks on my own research. I've used it in videos, like we produced a MOOC with like around 50 videos debunking the most common myths about climate change. And every video has the fact, myth, fallacy structure. And I've also even used it in a climate textbook. I wrote a college textbook where every chapter was a key aspect of climate change, but we framed it all as, here is the fact, here is a key aspect of climate change, here is a related myth, here's the fallacy that the myth uses, and then let's just reinforce the climate fact again. So that's a very versatile way to address misinformation in almost any format.
Right. Very good. Very good. So maybe one last call for questions. I think we've asked all the questions. If we didn't get somebody's question, if you want to pipe in real quick here at the end, because I don't want to leave anybody out. I think we've captured everyone. But with no more questions, I just a couple of tidy up end of the day notes. We did record the session, so we'll work on figuring out how to get that posted to share for the chapters who had people who couldn't attend who want to see it. And I did put the main Cranky Uncle game web link in the chat. I don't know if there's a better, you had the 3 links there, but I think if you go to that web page, it'll show you the ways to get to it. So hopefully if you're interested in that game, and like I said, I've downloaded it and I've played it, and I thought I pretty well understood those logical fallacies and whatnot, but certainly I've learned a lot in using it. So it's a fun way to, as you say, sharpen your skills there and I think become a better advocate for climate science. And one of the things I think that we're very much into respectful engagement. We want to respect everyone. And I think your techniques, give us good ways to do that in a respectful way. So I really appreciate the work you're doing and all we've learned from it. So any final words before we close?
Keep up the great work at CCL. I think that CCL is making a hugely important contribution. So thank you guys all for your work. Thanks also for the invitation to speak to you, and happy Earth Day.
Thank you very much. It was great. We really appreciate it.
Thank you.
So,
Happy Earth Day.
Yeah. And it was great seeing you, John.
Yeah, you too.
Thank you, John. And thanks everyone for attending.
Thank you everyone for coming. Yeah.
All right. I'm going to end it now. Good night, everybody.
Good night.
Bye.